theta divided by 1 minus tan squared theta can be written as tan 2 theta. 1 plus tan squared theta is secant squared theta. Or you can write it as 1 will be is equal to secant squared theta minus tan squared theta. A plus B, take tan to the side, what it will become? Tan inverse. If you are having cos inverse, you have to substitute what is cos 2 theta in the form of tan. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics Faculty, Vidhyaashram, Temple of Excellence, Mysuru. In this session, we are going to learn the topic called inverse trigonometric functions. Okay, so in the last session, we have learned about the properties and some problems which was asked for 1 marker and 2 marker. In this session, we are going to continue to solve the properties and also the problems based on this inverse trigonometric functions. So before moving on to the properties and solving problems, so I am going to give you the list of formulae which is very important to solve the problems as well as the properties. Okay, so these are all the formulas you are going to have it as. Here I have taken sin squared theta plus cos squared theta is equals to 1, which we have studied already in your first PUC. So be careful dear students, whenever you are having in the form of sin squared theta can be written as sin squared theta can be written as 1 minus cos squared theta, isn't it? So you know already, if you bring this cos squared theta this side, it will become 1 minus cos squared theta, or you can write it as cos squared theta can be written as 1 minus sin squared theta, isn't it? Cos squared theta can be written as 1 minus sin squared theta. This is basically from this formula only I am checking, right? So if you are having in the form of 1 minus, so 1 minus x squared in place of sine, I can take it as, or in place of x I can take it as sine, in place of x I can take it as cos. So if you are having in terms of 1 minus x squared, you are going to substitute, I am going to write it here, substitute x is equals to sine theta or x is equals to cos theta. Okay, this is a substitution you are going to take it as whenever it is in the form of what? 1 minus x squared. Are you getting? So similarly, if you are having, see, you know 1 plus tan squared theta is secant squared theta, or you can write it as 1 will be is equal to secant squared theta minus tan squared theta, isn't it? So if you are having in the form of 1 plus x squared, here I am going to write it as, if you are having in the form of 1 plus x squared, if you are having in the form of 1 plus x squared, you are going to substitute x is equals to, tan theta, Similarly, you can observe dear students here, this is not cot 2 theta, it is cot squared theta. If you are having 1 plus cot squared theta will be is equal to cosecant squared theta. So 1 plus. So therefore, you can substitute either tan theta or you can substitute cot theta, isn't it? So if it is in the form of 1 plus x squared, substitute x is equals to tan theta or substitute x is equals to cot theta. This is very important. Okay, next we'll be moving on to what is that? If you are having in the form of, see, 1 plus x squared is nothing but this. Now x squared minus 1. So don't confuse it between these. 1 minus x squared means sin theta or cos theta. 1 plus x squared means 1 plus tan squared theta, 1 plus x squared, 1 plus cot squared theta, 1 plus x squared. Either x is equal to cot theta or x is equals to tan theta. You are going to substitute. Next, if you are having in the form of x squared minus 1, if you are having in the form of x squared minus 1, you are going to substitute, see, you can observe here. So 1 can be written as secant squared theta minus 1. Here you can observe, here I am going to write it as secant squared theta, bring this plus 1 to this side, minus 1 can be written as tan squared theta, isn't it? Can be written as tan squared theta. Here also you can observe, what is that? Cosecant squared theta cosecant squared theta minus 1 can be written as cot squared theta. Cot squared theta. So therefore, if it is in the form of x squared minus 1, x will be secant theta. So therefore, I can substitute x will be is equal to secant theta or x will be is equal to cosecant theta. Okay, this is all very important. You are going to have it as, see, I am going to mark it. So this is all very important. 1 plus x squared, 1 minus x squared, substitute x is equals to sin theta or cos theta. If it is 1 plus x squared, substitute x is equal to tan theta or cot theta. If it is x squared minus 1, substitute x is equals to, what is that? Secant theta or cosecant theta. This you have to observe here. And similarly, we'll be moving on to the next type of the formulas. Is nothing but you can have it in the form of sin squared theta can be written as, it is not sin squared theta, it is sin 2 theta. Correct na? Sin 2 theta can be written as 2 sin theta into cos theta. Similarly, sin 2 theta can also be written in terms of tan, which is nothing but 2 tan theta divided by 1 plus tan squared theta. Please, dear students, observe this. In the denominator, you having 1 plus tan squared theta. Are you getting? Next, you are moving on to cos 2 theta, multiple angles. Correct na? Cos 2 theta can be written as cos squared theta minus sin squared theta. And cos 2 theta can also be written in terms of only sin, which is nothing but 1 minus 2 sin squared theta. Similarly, this can be written in terms of only cos, which is 2 cos squared theta minus 1. And in terms of tan, 1 minus tan squared theta divided by 1 plus tan squared theta. Isn't it? Next will be this, you understood, I think. Okay, multiple angles, and then you are going to have some of that. Sin squared theta plus cos squared theta is equal to 1. How we are going to represent, or how we are going to substitute in the form of, if it is there, x term. Okay. Now, if you are having same like here, in place of 1, if you are having like a or b, some another constant, 2 squared, 4 squared, like that, what you are going to substitute? Suppose, if you are going to have, let me change the color for that. So, if you are going to have in the form of a squared minus x squared. Observe, dear students, carefully. In the form of a squared minus x squared, you need to substitute. In place of a, you are having 1, that's it. Okay. A can be any constant, any real number. 2, 4, root 2, root 3, 5, 6, any real number it can be. So, if it is in the form of a squared minus x squared, substitute either x is equals to a sin theta, see, or x is equal to a cos theta. I think you understood this one. So here 1 sin theta, 1 into sin theta is nothing but sin theta only. Here 1 into cos theta is nothing but cos theta only. So that I'm not specifying it. 1 into sin theta, you know already it is sin theta. So here 1, if you write also, not write also, not a problem. So here if you are having in the form of a squared minus x squared, you have to write it, or you have to substitute x is equal to a sin theta, x is equals to a cos theta. Similarly, if you are having in the form of, what shall I write it here? So in the form of what? In place of 1 plus x squared, if you are having a squared plus x squared, if you are having a squared plus x squared, I think you came to know now what to substitute. So you are going to have x will be is equal to a tan theta, correct na? Or x will be is equal to what? A cot theta. This you have to remember. Next, if you are going to have in the form of what? X squared minus 1. So what are you going to substitute? X squared minus a squared, if it you are having, correct na? X squared minus a squared. So therefore you are going to substitute x will be is equal to a secant theta, or x will be is equal to a cosecant theta, correct na? A cosecant theta. So please, dear student, this and all the formulas of the substitution you have to remember. Okay. Next, we'll be moving on to how we are going to have multiples of tan. That is tan 2 theta. Tan 2 theta can be written as what? 2 tan theta divided by 1 minus tan squared theta. Please, dear students, observe here. So many of you will be getting confused in this. See, sin 2 theta can be written as in terms of tan 1 plus. So many of you will be writing here 1 minus. Don't write 1 minus, it is 1 plus tan squared theta. When it comes to tan 2 theta, denominator is 1 minus. Okay, so one logic I'm going to tell you. Remember any one formula from these two, whichever you are getting confused. So other formula will be in your mind itself. So it will come automatically. Okay, if you remember plus for what, sin 2 theta, automatically minus will be for tan 2 theta. That's it. Okay, so you are going to have it as your next sin 3 theta can be written as 3 sin theta minus 4 sin cube theta. Similarly, tan 3 theta can be written as 3 tan theta minus tan cube theta divided by 1 minus 2 tan squared theta. Next, tan of a plus b, isn't it? That is adding and subtracting an angle. So you are going to have tan of a plus b is tan a plus tan b. Suppose if you are getting here a plus b here plus, denominator minus, tan of a plus b can be written as tan a plus tan b divided by 1 minus tan a into tan b. Similarly, tan of a minus b can be written as tan a minus tan b divided by 1 plus tan a into tan b. So these are all very important formulas you are going to have it as, and these are all the substitution you have to know, okay, for the problems, for solving problems. Okay, next let us move on to solving the problems here. Prove that what they have given, tan inverse x plus tan inverse y is equals to tan inverse of x plus y divided by 1 minus x into y. Okay, so here they have given xy is lesser than 1. Okay, x into y must be lesser than 1. If it is greater than 1, it will be moving on to the negative term. So that here they have given the conditions y must be a lesser than 1. This property can be asked for one marker like this. Tan inverse x plus tan inverse y is equals to tan inverse of x plus y divided by 1 minus x into y. If what property, this property holds good for what values of x? Okay, or what values of x and y. So you have to write it as x into y is lesser than 1. Okay, that's it. So here let me prove this property. So if you look here, it will be looking like tan a plus tan b, like that, isn't it? So what I'm going to do is the substitution solution can be given like this. See, I'm going to take let tan inverse x is equals to a, okay, and then let tan inverse y is equals to b. Okay, as already know, if tan inverse taken to that side, it will become automatically tan. So therefore, x can be tan a, correct na? Similarly, y can be tan b, correct na? Y can be tan b, right? So here you are going to have it as what is tan of a plus b formula? Just now we have what is tan of a plus b? Tan of a plus b is tan a plus tan b divided by 1 minus tan a into tan b. Let me take this formula here. So what is that? I am going to write it in the other ink. What is that? Tan of a plus b is equals to tan a plus tan b divided by 1 minus tan a into tan b, isn't it? Now you are going to substitute what is tan a. Tan a is nothing but x. Substitute tan b is nothing but y. So therefore, by having a substitution, you can have which will be is equals to, see, I am going to substitute here. Tan a is nothing but x plus, same as it is, I am going to write it as tan of a plus b, okay, is equal to tan a is x plus tan b is y divided by 1 minus tan a is x into tan b is y, correct? So therefore, now we are going to have here, what is that? A plus b, take tan to this side, what it will become? Tan inverse. Therefore, I can write it as a plus b will be is equals to what is that? Tan inverse of x plus y divided by 1 minus x into y. We arrive the proof now. What is that? So a can be written as what? A is tan inverse x, substitute. B is tan inverse y, substitute. So therefore, I can have it as tan inverse x plus tan inverse y is equal to tan inverse of x plus y divided by 1 minus x into y. So this is a proof of your question, isn't it? Understood? Any doubt do you have? Yes. Okay, we'll move on to the next question. So next question they have asked as simple. Tan inverse x minus tan inverse y is equals to tan inverse of x minus y divided by 1 plus x into y. Xy is greater than minus 1. So here you are going to have the same method. What is that? Let me take that one as let tan inverse x is equals to a. Okay, and then tan inverse y is equals to b. Therefore, I can write it as tan a is nothing but x, correct na? And tan b is nothing but y. So what you are having here? Minus. Minus means which is the formula I can use it as? The formula I can use it as tan of a minus b is equals to tan a minus tan b divided by 1 plus tan a into tan b. Therefore, let me use that formula here. What is that? So I can use here tan of a minus b is equals to tan a minus tan b divided by 1 minus tan a into tan b plus, correct na? Into tan b. So here you are going to have it as, see. So let me take this one as what is that? Substitution. What is tan a? Tan a is x minus y divided by 1 plus x into y, correct now, which is nothing but in the left hand side tan of a minus b. So what is then a minus b will be is equals to a minus b is equal to, bring to tan this side, what it will become? Inverse. Tan inverse of x minus y divided by 1 plus x into y. That's it. Now substitute for what? A and b. A is nothing but tan inverse x. So therefore, tan inverse x minus tan inverse y will be equal to tan inverse of x minus y divided by 1 plus x into y. I think you understood this proof also. Just change the formula. Instead of plus, you are going to write it as minus here. That's it, right? So we'll be moving on to the next proof, which is very, very important. They have asked for what? The proof of the 3 marker in your NCERT paper. Okay, so before moving on to this problem, I would like to give you the properties of this one. What is 2 tan inverse x can be written as sine inverse of 2x divided by 1 plus x squared. Okay, and then I'll be moving on to that property. Let me prove this one first and then we'll be moving on to that formula proof. What is that? This is also a property. Prove that. Here I have to write it here. Prove that 2 tan inverse x is equals to tan inverse of 2x divided by 1 minus x squared. So let me prove this property first. So here proof will go like this here. You can have it as, since you are having tan on both the side, either you can take the right hand side and prove the left hand side, or left hand side prove the right hand side. So here I am going to take the right hand side and prove the left hand side. Okay, what is that? Let RHS, what is that? RHS is tan inverse of 2x divided by 1 minus x squared. You know, in terms of tan, what is tan 2 theta can be written as? Tan 2 theta can be written as what? 2 tan theta divided by 1 minus tan square theta, isn't it? So here I am going to write the formula. What formula it is? Tan 2 theta can be written as 2 tan theta divided by 1 minus tan squared theta. So in place of x, if you substitute, what it will become? 2x divided by 1 minus x squared. Correct na? You can observe. 2x divided by 1 minus x squared. What is the substitution I have to do? Tan theta. So therefore here I am going to do the substitution. What is that? Put x is equals to tan theta. Dear students, observe that if x equal to tan theta, what is theta will be is equal to? Theta will be is equal to, Bring tan to that side, it will become tan inverse x. This is important, okay? Substitution as well as theta will become tan inverse x. Now let me move the property proof. What is that property proof? I have taken the RHS. I am going to substitute x equal to tan theta, and then I am going to get it as which implies tan inverse of 2 tan theta divided by 1 minus tan squared theta, which can be written as tan inverse of, dear students, please see here, 2 tan theta divided by 1 minus tan squared theta can be written as tan 2 theta. So therefore 2 tan theta divided by 1 minus tan squared theta can be written as tan 2 theta. So I am going to write it here the same, tan 2 theta. Okay, if I am going to write it as tan 2 theta, what is tan inverse tan? Will go, you are going to remain with what? 2 theta, isn't it? You are going to remain with 2 theta. What is theta? That's what I have written here. Theta is nothing but tan inverse x. Therefore, I can write it as, which will be is equals to 2 tan inverse x. What is this? This is nothing but the left hand side. So therefore, which will be is equals to the left hand side. So right hand side I have taken, then I have proved for the left hand side. Are you getting this? Any doubt do you have in this proof? Just you have to remember this formula for substituting. Understood this one? So this proof will be also asked for a 2 marker, or it may sometimes ask for 3 marker also. Are you getting this one? So by keeping this formula on mind, we'll be moving on to solving this problem, which is the problem I have given here. This is the problem I have given, correct now? So here, what is the problem? 2 tan inverse 1 by 2 plus tan inverse 1 by 7. Here to write here, prove that. This problem is a very important problem which was asked repeatedly for 3 marker in your examination. Are you getting this one? So let me move on to this proof now. So here you can observe it is in the form of 2 tan inverse x. Just now we have proved. What is that? I am going to write it here. 2 tan inverse x. 2 tan inverse x can be written as tan inverse of 2x divided by 1 minus x squared, isn't it? So therefore we are going to use in place of x what we are having here, 1 by 2. So therefore first I am going to take this one. What is that? So I am going to do it as in blue color. So therefore here 2 tan inverse 1 by 2 can be written just for this one I am writing, okay, just for this. Then I am going to combine, okay. So 2 tan inverse 1 by 2 can be written as what? Can be written as tan inverse of 2x, 2 into 1 by 2 divided by 1 minus x squared, 1 by 2 whole squared, okay. So observe carefully, which will be is equals to what? Tan inverse. What it will be here? 2 and 2 will be getting cancelled, isn't it? So what it will become? So it will be 2 and 2, if it is get cancelled, 1 divided by 1 minus 1 by 2 whole squared is the what? 1 squared is 1 divided by 2 squared is 4, correct na? So therefore which will be is equals to tan inverse of what is that? 1 divided by 4 into 1 is LCM is 4. 4 minus 1 divided by 4, correct na? So therefore which can be written as? Which will be is equals to, what is that? Tan inverse of 1 divided by 4 minus 1 is 3 divided by 4. Now this 4 will go to the numerator. So what you are going to have it as? So 2 tan inverse 1 by 2 can be written as tan inverse of 4 by 3, correct na? This is very important, okay. For this I am going to substitute 2 tan inverse 1 by 2 can be substituted as tan inverse 4 by 3. If you want, you can do along with the problem by taking this plus sign also. Left hand side I am taking, I am going to prove the right hand side. Just for your sake of how it will be converted, I have shown you. But this step you have to follow in your examination. Are you getting? So I am going to follow next, which will be what? See, 2 tan inverse 1 by 2. I am going to write it here. I'm going to write the formula. What is that? Sorry, problem 2 tan inverse 1 by 2 and then plus tan inverse 1 by 7 plus tan inverse 1 by 7. Correct na? So what I have substituted, I can have the substitution here. What is that? You are going to have it as 2 tan inverse 1 by 2 can be written as tan inverse 4 by 3. But this step must be followed there. Are you getting? So therefore I am going to write it here, tan inverse 4 by 3 plus tan inverse 1 by 7. So this is your what? The left hand side. Correct na? I have taken. Okay. So in place of this, you have to write down these many steps. Got? Along with this, you have to continue. Got? So next we'll be having what? Tan inverse 4 by 3 plus tan inverse 1 by 7. See, this is be looking like what? Tan inverse x plus tan inverse y. So therefore, I am going to write that formula here. What is that? Tan inverse x plus tan inverse y. Just now we have proved, which will be is equal to tan inverse of x plus y divided by 1 minus x into y. Are you getting this one? Therefore, you are going to use that formula here. What is that? In place of x, you are going to have 4 by 3. In place of y, you are going to have 1 by 7. So therefore, by writing that, so that is tan inverse, what is that? X plus y, that is 4 by 3. Plus 1 by 7 divided by 1 minus 4 by 3 into 1 by 7. Correct na? Is that right? What I have substituted? Now which will be is equals to, which implies, this is LHS I have taken, tan inverse of 4 by 3 plus 1 by 7. Taking LCM is 21. So therefore you can take it as LCM is 21. So 7 4s are 28 plus 3 1s are 3, correct na? Divided by whole over. Again here also 7 3s are 21. So you are going to have 21 into 1 is 21 minus 4 1s are 4 divided by 7 3s are 21 is LCM, correct na? So therefore you are going to have 21 and 21 will get cancelled. You are going to remain with what? You are going to have LHS implies that tan inverse 28 plus 3. What is 28 plus 3? 31. So tan inverse 31 divided by what is 21 minus 4? 17 divided by 17. Which will be is equal to, you can see the problem, tan inverse of 31 divided by 17. Tan inverse of that is RHS, right hand side. Therefore, you can have 2 tan inverse 1 by 2 plus tan inverse 1 by 7 is equals to what? Is equals to what we have proved, tan inverse of 31 divided by 17. This is your proof. You understood the proof, I think. First I have used this formula. Which one? 2 tan inverse x divided by tan inverse 2x divided by, to reduce to the form of tan inverse. This one. This step must be followed along with this. Okay. You are going to write this both together, and along with this step, you are going to write tan inverse 1 by 7 as it is, and then after reducing till here, you are going to follow this formula, tan inverse x plus tan inverse y, and prove the right hand side, whatever it is, that is tan inverse 31 divided by 17. This problem is very important, which will be asked for your 3 marker. Understood? Any doubt do you have in this? Any doubt do you have in this? Yes, okay. I think you understood this problem. 2 tan inverse 1 by 2 plus tan inverse 1 by 7 can be proved as what? Tan inverse 31 divided by 17. Okay, so next we'll be moving on to the next, which will be tan inverse 2x. Prove that or find the value, not prove that, find the value of x. Find the value of x. Find the value of x. If tan inverse 2x plus tan inverse 3x is equals to pi by 4. Okay, so is it look like the same as tan inverse x plus tan inverse y? So I am going to take that formula. What is that? Tan inverse x plus tan inverse y is equal to tan inverse of x plus y divided by 1 minus x into y. Okay, so same I am going to use it as, in place of x you are having 2x, in place of y you are having 3x. Okay, so therefore you are going to have here tan inverse of, what is that? You can take the left hand side. I am going to take the left hand side, which implies that tan inverse 2x plus tan inverse 3x. Otherwise, let me take the whole term, okay? Because pi by 4 they have given. Let me take the whole term here. Instead of taking the LHS and RHS, they have given like this. So I can write in place of the same formula, what it will be? Tan inverse of, in place of x, you are going to have 2x plus tan inverse y, in place of y, you are going to have 3x. Correct, na? So here I am going to write it as, what is that? In place of x, 2x, in place of y, 3x, divided by 1 minus, what it will be? 2x into 3x. Correct, na? 2x into 3x, close the bracket, which will be is equals to pi by 4. Isn't it? Now, what I am going to do is, this tan inverse, I am going to take it to that side. So what it will become? So it will become, as here on 2x plus 3x. What is 2x plus 3x? Which is nothing but 5x. So therefore you are going to have it as tan inverse of 2x plus 3x is 5x divided by 1 minus 2x into 3x. X and x will be multiplying here. So 2 into 3 is 6. X into x is x squared. Correct, na? 2x into 3x, which will be is equals to pi by 4. Now I am going to take tan on both the side, or shifting this tan inverse to that side. So it will become what? What it will become? So you can have 5x divided by 1 minus 6x squared is equals to tan pi by 4. Isn't it? Tan pi by 4. So you are going to have, what is tan pi by 4 value? Tan 45 degree. What is tan 45 degree? 1. So therefore you can substitute the value of tan pi by 4. 5x divided by 1 minus x squared will be is equal to tan pi by 4, your value is 1. Therefore shifting this denominator to the right hand side, 1 into 1 minus 6x squared is 1 minus 6x squared only. Therefore 5x will be is equal to 1 minus 6x squared. Isn't to look like the quadratic? Yes. You can bring all the term to the left hand side. Now what it will become? 6x squared plus 5x minus 1 is equals to 0. Isn't it? Right? So therefore you are going to have it as here the quadratic equation. If you multiply, you have to get 6. If you add, you have to get it as 2. So what are all the terms? Sorry, if you add, you have to get it as 5. What are all the factors you are going to have? You are going to have the factors as what? Either 3 into 2, or it can have 6 into 1. Isn't it? So here you can have it as 6x squared plus 5x. Can we take it as 3 and 2 common here? Okay? No, so therefore you are going to have it as 6 into 1. 6 minus 1 is nothing but 5. You can write it as, therefore I am going to write it as 6x squared plus 6x minus x minus 1 will be is equal to 0. Right? So therefore here I am going to write it as 6x will be taken in common. Therefore you are going to have it as what? X plus 1 minus 1, you can take it as x plus 1, isn't it? Is equal to 0. Now we are going to have, what is that? What is that? 6x plus 1. 6x minus 1 is equal to 0, or you can write it as what? X plus 1 is equal to 0, isn't it? Therefore, 6x minus 1 equal to 0 means what? X will be is equal to 1 by 6, correct na? X plus 1 equal to 0 means what? X plus 1 equal to 0 means x will be is equal to minus 1. Correct? You are going to have it as. Therefore, these are all the two values you are going to have it for x is equal to 1 by 6 and x is equals to minus 1. Hope you clear this problem. Next, we'll be moving on to what? The properties. Okay? These are all the properties, or you can take it as problems also. Okay? Prove that. You have to write it here. Prove that 2 tan inverse x is equals to sine inverse of 2x divided by 1 plus x squared. You can remember the formula what I have given first. That is nothing but, see, you can have sine 2 theta because you are having in terms of sine inverse. So bracket also it should be in the sine because sine inverse will go. So therefore I am going to write it in the form of sine 2 theta can be written as in terms of tan 2 tan theta divided by 1 plus tan squared theta. Okay, so therefore here I am going to take the right hand side and then I am going to prove the left hand side. Okay, so this will be also asked for what? A 2 marker. So here I am going to take the right hand side. See here, right hand side is what? Right hand side can be taken as sine inverse of 2x divided by 1 plus x squared. Correct na? Now what you are going to substitute? Substitute, put x equal to, put x is equals to, what is that? You are going to take tan theta. Isn't look like that? 2 tan theta divided by 1 plus tan squared theta. Therefore, what is theta will become? Theta will become, bring tan to that side, it will become tan inverse x. This is important. Okay? Tan inverse x. Okay? And this is also important. Substituting is equals to a theta. Tan x is equal to tan theta. Now we are going to have it as what? You can implies that sine inverse of 2 tan theta divided by 1 plus tan squared theta. Right? Sine inverse of 2 tan theta divided by 1 plus tan squared theta. Now what is this? This is nothing but sine 2 theta. So I am going to substitute that, which implies that sine inverse of sine 2 theta. Okay. Now sine inverse will go. What you are going to have? Which implies that sine 2 theta, sine inverse of sine 2 theta is 2 theta. Now what is theta? Theta is nothing but tan inverse x. Therefore, which implies that 2 tan inverse x. Isn't we proved the left hand side? Yes, 2 tan inverse x. Therefore, which is nothing but the left hand side. Okay, you are going to have it as left hand side. So I can have here the left hand side as what? So which will be is equals to the left hand side. So right hand side we have taken, substituted the formula which is in the terms of sine 2 theta, because sine inverse you are going to have. If you are having cos inverse, you have to substitute what is cos 2 theta in the form of tan. Like that. Okay, we'll be moving on to the next property or the problem. So prove that here also same I told you. Cos inverse is here. You're going to have prove that 2 tan inverse x is equals to cos inverse of 1 minus x squared divided by 1 plus x squared. Okay. So you're going to have x must be greater than or equal to 1. This is very, very important. The same problem they have asked for a 1 marker. They have given this property 2 tan inverse is equal to cos inverse 1 by x squared divided by 1 plus x squared. What this property which will be holds good for what values of x? That means you have to write down this for x greater than or equal to 0. That is very, very important. They will be asked for a 1 marker. Okay, now here also I am going to take the right hand side, then I am going to prove the left hand side. Okay, so here I am going to write, since in terms of what? Cos inverse, inside also it should get in terms of cos only. Therefore, I am going to write down the formula which is in terms of cos, which will be in terms of what? Cos, it will be in terms of tan. So that is cos 2 theta. Cos 2 theta can be written as 1 minus tan squared theta divided by 1 plus tan squared theta. Isn't looked like 1 minus x squared, 1 plus x squared, already x squared is there, x is what? Tan theta. That's it. So therefore you are going to have it as taking the left hand side implies that, what is that? Cos inverse of 1 minus x squared divided by 1 plus x squared. Now I am going to put that, what is that? Put x is equals to tan theta, correct na? If x equal to tan theta, what is theta will be is equal to? Theta will be is equal to tan inverse x, okay? So therefore at last we can substitute. Now we are going to have it as, so which implies that LHS, which implies that, okay, cos inverse of 1 minus tan squared theta divided by 1 plus tan squared theta, okay. So therefore you can substitute 1 minus tan squared theta divided by 1 plus tan squared theta is cos 2 theta. Therefore which implies that cos inverse as it is you are going to write, this is nothing but cos 2 theta. You are going to substitute cos 2 theta. Now cos inverse cos will go. You are going to have 2 theta. What is 2 theta? Theta is nothing but what? Tan inverse x. Substitute. So therefore 2 tan inverse x, correct na? 2 tan inverse x, which is nothing but what? Which is nothing but RHS. I have taken the RHS, then I am proving the LHS, left hand side. This is the right hand side, this is the left hand side, okay? So therefore right hand side I have taken and then I am going to prove the left hand side, okay? That is 2 tan inverse x. I think you understood this property or the problems, okay? Next will be moving on to what? We have already proved this one just now to use it in the problem. 2 tan inverse x can be proved as tan inverse 2x divided by 1 minus x squared. If you want, I'll repeat again. RHS I have taken 2 tan theta divided by 1 minus tan squared theta. I have given the formula. Then I have substituted. I have got LHS, left hand side. Are you getting this one? These 3 properties are very, very important, which will be asked for 2 marker or it can be asked for a 3 marker also in your final examinations. Okay. So next we'll be moving on to prove that sin inverse 2x root of 1 minus x squared is equal to 2 sin inverse x for x greater than or equal to minus 1 by root 2 or lesser than or equal to 1 by root 2 or not lesser than or equal to 1 by root 2. You have to prove this property now. Now I am going to take, since you have to observe the right hand side. What are you having? Sin inverse. So therefore in place of x I am going to substitute sin. If you are having right hand side cos, you have to substitute cos theta. Okay. Now I am going to take the left hand side. Then I am proving the right hand side. So therefore here I am going to take the left hand side. Okay. Sin inverse of 2x under root 1 minus x squared. Now I am going to substitute. What is that? Put x is equal to sin theta. Why I am particularly sin theta? Because I am having in right hand side sin. Okay. Next you are going to have, what is theta can be replaced? Theta can be replaced as sin inverse x. Okay. So therefore here I am going to write down that, what is that? Sin inverse of left hand side implies, okay, implies sin inverse of 2 into tan theta. I am going to open the bracket since I am doing the substitution. 2 sin theta under root 1 minus x squared, that is sin squared theta. Okay, sin theta whole squared is sin squared theta. Cos theta whole squared is cos squared theta. Cos theta whole cube is cos cube theta. Therefore, cos theta whole power n is cos power n theta. Sin theta whole power n is sin power n theta. That's it. Okay. So therefore, you are going to have 2 sin theta under root 1 minus sin squared theta. But what is 1 minus sin squared theta? As we learnt already, 1 minus sin squared theta can be written as cos squared theta. Substitute that here. So what it will become? LHS can be written as sin inverse of 2 sin theta under root 1 minus sine squared theta can be written as cos squared theta. Correct na? Now root and root will get cancelled. This and this. Correct na? Root and root will get cancelled. You are going to remain with what? Sine inverse of 2 sine theta into cos theta. What is 2 sine theta into cos theta? Multiple angle sine 2 theta. Therefore, I am going to write that formula also. See here, sine 2 theta is nothing but 2 sine theta into cos theta. Similarly, 1 minus sine squared theta is equal to cos squared theta. I am writing here what and all I am going to use it. Okay. So next we are going to have the proof continuation here. 2 sine theta cos theta can be written as what? Sine 2 theta. Isn't it? Therefore, by writing that sine inverse of sine 2 theta. Sine inverse will go. You are going to remain with what? 2 theta. Now what is theta, dear students? Theta is nothing but sine inverse x. Therefore, you are going to have, which implies 2 sine inverse x, which is nothing but what? You are going to have it as the right hand side. You understood now? If it is there sine in the right hand side, substitute for the left hand side sine theta. That's it. Okay. This is also very important, which will be asked for a 2 marker in your final examination. Next we'll be moving on to see. I told you sine inverse of 2x into root of 1 minus x squared. You have to prove this. Okay. Prove that sine inverse of 2x into root of 1 minus x squared is equal to 2 cos inverse x. So right hand side what you are having? Cos inverse x. This may ask also the property for what values of x it will be holds good. That x will be greater than or equal to minus 1 by root 2, lesser than or equal to 1. Okay. So next you are going to have what? Put substitute cos. So therefore you are going to have, taking the left hand side, what is that? Sine inverse of 2x into root of 1 minus x squared. What is the substitution you are going to do? Substitution, put x is equal to cos theta. Now theta can be written as what? Cos inverse. Theta can be written as cos inverse x. Correct na? So cos inverse x you are going to write it as theta. Therefore, you can have that substitution for the left hand side here. What is that? Which will be equal to sine inverse of 2 cos theta. X is cos theta under root 1 minus cos squared theta. Now you are finding out under root 1 minus cos squared theta is what? It is nothing but sine squared theta. Here I am going to write 1 minus cos squared theta is nothing but sine squared theta. Correct na? So therefore I am going to have here, which will be is equals to, implies that sine inverse of 2 cos theta under root sine squared theta. Correct na? Now root will go. So you are going to have, which implies that sine inverse of correct 2 cos theta into sine theta under root, and the square will go, right? So now what is 2 cos theta into sine theta? 2 cos theta into sine theta. I am going to write here 2 cos theta or sine theta, or 2 sine theta into cos theta is sine 2 theta. Right? So I am going to write it here sine 2 theta. Therefore, you are going to have sine inverse of sine 2 theta. What is that? Sine inverse, sine will go. You are going to have 2 theta. Correct? So 2 theta is nothing but 2. What is the theta? Cos inverse x. Now you can observe, dear students, we have proved what? The right hand side. Correct na? So right hand side is 2 cos inverse x. Understood now? Any doubt in this? If it is there sine, put x equal to sine theta. If it is there cos, put x equal to cos theta. The same procedure you are going to follow for this and this problem. Okay, you are going to have it as. For this problem and this problem, same proof. You are going to have just the substitution will change according to the right hand side. Got? So next we'll be having 3 sin inverse x is equals to sin inverse of 3x minus 4x cube. For this you have to remember the multiple of submultiples of sin 3 theta. Sin 3 theta can be written as what? 3 sin theta minus 4 sin cube theta. Correct? So therefore I am going to use that formula here. What is that? You are going to have sin 3 theta can be written as 3 sin theta minus 4 sin cube theta. Okay. So by using that formula, so where I have to use? Now you are getting. I am going to take the right hand side, then I am going to prove the left hand side. That's it. Because in place of x, what you are having? Sin theta. That's it. What is the substitution you have to take? Sin theta. Therefore, you are going to have here, I am going to choose the right hand side. RHS. Prove that, okay, will be, what is that? You are going to imply sin inverse of 3x minus 4x cube, which is nothing but what? You are going to have put, I am going to substitute here, put x is equals to what? You are going to take it as, why? Because I am taking sin inverse is there, inside sin only you should get, sin and sin inverse will go. So therefore put x is equal to sin theta, right? So therefore theta will be is equal to what? Sin inverse x, correct? Sin inverse x. Now we are going to have that, what is that? The right hand side sin inverse of 3 into sin theta minus, I already told you, sin theta whole cube is what? Sin cube theta. So therefore 4 sin cube theta. Okay. So you can have here arrow mark. Please don't forget about that. Then which will implies, see, which implies sin inverse of, what is 3 sin theta minus 4 sin cube theta is nothing but what? It is sin 3 theta. Therefore, I am going to substitute in place of this sin 3 theta. Therefore, sin 3 theta, you can observe, dear students, sin inverse sin will go. You are going to remain with 3 theta. Correct now? What is theta now? Theta is nothing but sin inverse x. Correct now? So, which implies 3 sin inverse x, which we have proved what? The left hand side. Correct? Which we have proved for the left hand side. Any doubt do you have in this? According to the substitution of the left hand side, I am taking here, or according to the formula, I am choosing what to substitute. Okay, we'll move on to next. Properties in the next session. So till now we have covered what? All the problems regarding the properties of tan inverse x plus tan inverse y, and then properties regarding the proof of 2 sin inverse x, 2 cos inverse x, 3 cos inverse x, 3 sin inverse x. Okay. So next class, and the formulas, that is very, very important. Next session will be moving on to some more problems by using the formulas and well as by using the properties, which and all I have proved in this session. Are you getting? Thank you, dear students.